Welcome to the Foundry by Forge College. So, in our previous lesson, revisiting blockchain philosophy, we spent some time lounging in the philosopher's armchair, discussing the high-minded principles of trust, transparency, and decentralization. But now, well, it's time to put down the espresso, get out of the armchair, and step right up to the engineer's drafting table. This explainer is all about translating those abstract ideas into hard, measurable engineering realities. Because let's face it, out in the real world, philosophy actually has to meet the pavement.
Okay, here is our master schematic for today. We're going to cover philosophy meets reality, the core evaluation rubric, a 7-step workflow, a real-world case study, toolbox versus architecture, and finally, capstone prep.
All right, let's jump straight into Section 1, Philosophy meets reality, bridging the abstract and the real.
Now, don't get me wrong here. Philosophy is a wonderful thing. It gives us our fundamental why. But you absolutely cannot build a structural bridge or, pass a capstone project out of good vibes and abstract thoughts alone. So that poses our foundational question. How on earth do we actually measure a philosophy? How do we take a lofty, sky-high ideal like decentralization or open-source ethos and turn it into physical items we can literally check off on an inspector's clipboard?
Well, the answer lies in operational criteria. We have to convert our core values into hard data, and we do that by asking 3 very specific things. First, what is this value actually protecting or enabling? Second, what observable signals show that this value is functioning out there in the wild? And third, how do we measure it numerically or descriptively? It's all about making the invisible visible.
Moving on to Section 2, the core evaluation rubric, mapping value.
So this right here is your primary engineering blueprint. It's a game changer. It takes a philosophical value like provable execution and maps it straight to a practical criterion like verifiability. Then it gives you concrete signals to look for. Think formal specifications and public audit artifacts. It also forces us to face the common trade-offs like slower development and higher costs. Or take decentralization. We measure that by the distribution of control, specifically looking for validator diversity, while acknowledging the very real trade-off of operational complexity. It's an incredibly powerful cheat sheet for your work.
And hey, while we're getting super technical, we absolutely cannot forget the human element. Social impacts are entirely part of this rubric, and they must be measured. We evaluate equity through participation demographics. We measure accessibility by looking at the actual cost thresholds to enter the network. And we measure accountability by ensuring there are clear, transparent dispute resolution paths. I mean, let's be real. A system just isn't practically successful if it excludes the exact people it's supposed to empower.
Let's keep rolling. Section 3, 7-step workflow, the assembly line.
All right, here's how this 20 to 40-minute evaluation process actually kicks off. Step 1, define the problem and clearly list the stakeholders. Seriously, who wins, who risks harm, and who has to actually approve the changes. Step 2, state your philosophical priorities and rank them. Step 3, run that observable signal checklist we just saw in our rubric. And Step 4, quantify the impact. You're going to assign a simple score from 0 to 3 for each criterion. And let me tell you, assigning a cold, hard number to a warm, fuzzy philosophy, that can be a pretty harsh reality check.
Case in point, you might find yourself having to assign a big, brutal 0 for decentralization when you suddenly realize your supposedly trustless, hyper-decentralized system actually relies entirely on one guy named Gary and his rusty filing cabinet down in the basement. It happens way more than you'd think. So absolute honesty is absolutely critical in Step 4.
Rounding out the workflow, we have Step 5, map out the stakeholder trade-offs. If you've got strong, provable execution, who benefits and who gets excluded? Now, Step 6, this is your kill switch. Check for practical blockers like legal constraints or data residency requirements. If a legal blocker is decisive, well, it completely rules out a blockchain solution, regardless of how beautiful the philosophical fit is. And finally, Step 7, produce your final verdict and a concise reasoning paragraph backed up by solid evidence.
Next up, Section 4, Real-World Case Study, Municipal Land Registry.
Let's actually test this assembly line on a municipal land registry. Our stakeholders, the residents, the registry office, and the banks, all demanding provable execution and accountability. But in the real world, we observe deep centralization and existing paper trails everywhere. And the ultimate kill switch here? Massive legal friction. What's brilliantly exposed here is the immediate, almost unavoidable tension between the high ethical stakes of land ownership and massive, unmovable legal blockers.
So what's the practical engineer's final verdict in this situation? Because of those legal blockers, we don't just rip up the entire foundation of the registry. Nope, we declare a conditional fit.
We adopt privacy-preserving verifiable records as an adjunct, basically a surgical fix added to the existing systems, rather than trying to force full decentralization where it literally, legally cannot exist.
That brings us to Section 5, Toolbox versus Architecture, Resolving Conflicts. Let's compare these two frameworks, because this is a vital mental model. Think of the toolbox mode as a handyman fixing a single leaky pipe. It's a specialized, narrowly scoped instrument you pull from a kit to fix one specific trust failure, like, say, setting up a tamper-evident log. But architecture mode, oh, that's bulldozing the house and pouring an entirely new foundation. It rewrites decentralized governance system-wide and completely redistributes power across the entire application. To figure out your approach, ask yourself this simple question. Can a narrowly scoped ledger solve the specific trust failure without ripping up the entire user flow? If your answer is yes, then your problem can be solved pragmatically with a toolbox approach, without forcing complex decentralization across the entire system.
On the flip side, ask yourself, does the problem require changing who controls system upgrades, data access, and dispute resolution across the whole application? If the answer is yes, the system is fundamentally broken at the root level. You are firmly in architecture mode, and you must take on the high coordination costs of full foundational decentralization.
Finally, Section 6, Capstone Prep Drafting the Blueprint.
Okay, here is your actual mission as you prepare for your final project in this Blockchain Fundamentals module. Select 2 candidate problems. I highly recommend finding one that looks like a super clear fit and one that seems like a marginal fit. Then, run the 7-step workflow for each of them. Write a clean 1-sentence problem statement. Note down your ranked priorities and your checklist scores. And finally, draft a 1-paragraph verdict. Always attach concrete evidence and state your trade-offs clearly.
I want to leave you with this final, kind of provocative thought to chew on as you start your evaluations. Look closely at the real-world problems you want to solve and ask, does your problem require a surgical tool or a whole new foundation? Make sure you actively apply the criteria we learned today so you don't just default to your ad hoc intuition.
Well, thank you so much for joining me today. This explainer was produced by Forge College, and I really hope it helped you see how to transform philosophy into practical engineering action. I highly encourage you to visit the website at forge.college to learn more about this subject and explore a wealth of other Web3 educational resources. Stay curious, keep building, and I will see you in the next explainer.